We're going to talk about encoders and decoders. So an encoder is a combination circuit that produces the output binary value of the output based on what the input is. So let me just show you a box picture of what we're talking about. Let's say I have a 4 to 2 encoder. I have inputs, maybe I'll call them I for input, 0, 1, 2, and 3. I have 2 outputs. I'm just going to call them D for data. So I'm going to get a number here based on which of these is set. So if I were to draw the truth table, this will look a little different than what we've done before, but I'll do it this way. All right, okay. Only one of my inputs can be set. So either input 0 is set, or input 1 is set, or input 2 is set, or input 3 is set. And then my output from this will be 0, 0, 0, because input 0 is set to 1, 1, 0, 1, because my input 1 is set, input 2 is set, input 3 is set. So this is an encoder. If you read the text, you can work through how you would get to this using the basic logic gates, AND gates and OR gates, and inverters. In fact, we can even look at it to set both outputs 0. We could use a simple set of AND gates. We look at this. If I run I0 into both of these, that will make sure that's set to 0. So I can do this. I'm not going to, because of my limited page and setting up how to build it, I'm not going to work through it all, but you can take a look at that. So that's my encoder. And instantly the text goes into this in detail. Decoder will work the opposite direction. I'll have an input with 2 values, and then I will set one of those 4 out. So let's just call this A. And I'm going to have a select 3, select 2, select 1, select 0. If I select 0, I'm going to set that one. If I select 1, I'll set this one. If I select 2, I'll set this one. If I select 3, I'll set this one. And my other values are 0. So my encoder and decoders are just about looking for a specific value that got set, or that I want to set, and then taking that binary number and representing it, or using the binary to set it. So we might use this in an application, for example, where we're trying to set which of the inputs for, say, a computer we want to be polling at the time and seeing if it has new information. So we might go through in a very simple computer and have our CPU put out a number that says, we send a signal, maybe we set S0 to the mouse, and we send the thing off to the mouse, say, hey, you got information to give me. 1 might go to the keyboard. The 2 might go off to an input like a USB or something like that. So we could use that just in that simple example to poll each thing we have. The reverse can happen here, where something receives information, it will set itself to 1, and then we see that come in and say, oh, that device has something ready to go. That'd be a simple use of our encoder and decoder. So with that, we're going to take an actual one. We're going to use a 74 LS 138. And what I'll tell you to do when you see these is you can just pull up the pinout. And if you do that, you'll probably just get this image, which is going to show you, if I look at the chip, pin 1 through 8, pin 9 through 16, it lists all the values. Now, it's very tempting to get that pin out, especially if you're looking at it on a phone, and just go, okay, that way I can see what the connections are. I'll tell you, you almost always want to get on the computer and pull up the actual data sheet and look at it. Now, the data sheet's going to be several pages long, so I wouldn't print it all out. And in fact, if I were building one of these where I had the computer screen available to you also, I'd just pull it up on that screen and show it to you. But in this case, I printed the first couple pages out, and sorry, I have an invader. If I go to the second page, by the way, if you just look at here, it'll actually give you a picture of here is what my decoder looks like. So I have a 3-input decoder, 8. It's called a 3 to 8 decoder. So whatever binary value these three numbers represent, we're going to set that specific output. Notice this is actually built with NAND gates and with a couple of inverters. The important thing is I get down to this truth table, and this truth table shows me inputs A, B, and C, and it shows me what's going to be set for those. So if I go back to here, A, B, and C are going to be the inputs. Y0 through 7 are my outputs. That's great. However, I do look here, and there's a G1 and a G0 to A and a G0 to B. And those are all some sort of enables. I know that from experience. You probably don't know what they are when you first look at them. So I need to look on the truth table on the next page to figure out where to put those. Okay, VCC and ground I didn't mention. In fact, on my board, I've already hooked those powers up. Okay, so if I go here, I can look down and notice if G1 is low, then my outputs are all high. That means I haven't enabled it. So I need it high for it to work in its normal mode. And if you look here, if I set G0 high, that's going to set all these high also. So really I want my G0 low and my H high. And I'm going to look down here, and G0 2 says that's equal to G0 2A or G0 2B. Sorry, I've got a helper moving around that's trying to get in stuff. Okay, so I put my IC on the board. I'm going to leave this where we can hopefully see it. We got power already connected, ground already connected. I put power and ground to this IC. And looking at that, I need G1 to go to high. So I'm going to get a short little wire, and I'm going to take G1, which when I look back at the pinout is number 6. 1, 2, 3, 4, 5, 6. And I'm going to take it up to positive, and that's going to be one of my enables. And all that's doing is making sure that this chip is set up and ready to run. Okay, G2 naught needs to go low. So let's take a short little wire and take it low. I got a little black wire over here this side if I can grab it. So G2 is 4 or 5. Now we're going to try this at first. I believe we can set both of those and it'll be fine. I'm going to try just setting one of them eventually, but for now I'm going to set them both. So at this point my chip should be ready to use, should be enabled. So those three set it up and enable it to operate. Almost all these combination circuits have a set of enables you need to set. And that lets you turn the chip on and off. Now I need A, B, and C are my inputs. And again, if I look at my pin out, that's 1, 2, and 3. So all I'm going to do is take a wire. A was number 1. So I'm just going to put these in order. I'm just going to use these 3, 4, 5, and 6 up here. So there's A. B. And I'm going to tell you, make sure you check these, because sometimes they do not do them in the most logical order. This one does. Sometimes they'll mix and match them, so you just want to pay attention. So again, I'm just being very systematic about this. All my inputs are now connected. Okay, now if you're going to demonstrate this for me, you're going to want to end up hooking up the lights for my 8 outputs. You have 8 lights, and you can run wires up to that. Because in this case, I'm just doing the demonstration for you, I want to keep it as clean and simple as possible. So I'm not going to worry about the lights, and I'm just going to use the logic probe to test it. So I'm going to turn power on, my light stays on, and it's good. I'll go ahead and drop my logic probe here, but I also need to set my voltage to 5 volts, so we'll go ahead and do that. I think I'm going to be high enough voltage to do anything right now. So get down here, turn this up to 5. Again, be careful with these voltages. If you were doing something else on here that had a 9 or 10 volt, you're not going to want to leave it there very long, because these digital ICs aren't going to stand up to it long. Okay, so we're just going to check it to start with. We know that if my 3 inputs are 1, which is where I have them set, I ought to get, looks like this is active low, so that's number 7. We're going to see what it is. So we're going to see what number 7 is. It's over here by itself. Okay, it's set low. All the others are high. Okay, now I am going to warn you of something. This may seem backwards to you. This is common that this one is active low. That means that if the one I've selected is 0 and everything else is high. Let's go over and let's try 0. So that should set 0. This one should be a 1 now. We're going to find whichever one's 0, then we'll check on our pinout. So that looks like pin number 9, 10, 11. 9, 10, 11. That's pin 4. Well, now that's concerning. So my inputs are aha, that one's not connecting. See that? So that's my problem. Got shoved in there too far. So that would be pin 0. If I want to set 1, see 1, and I should go through and check them all. For now, we'll just move quickly. 2, 3, 4. Again, I should be checking them all each time. I'm just not here because I'm moving quickly. 5, 6, and finally 7 again. Alright, so when you build these, you just want to build them and go through every possible combination and note it. And once again, when you're doing your demonstration for me, you're not going to want to necessarily sit around with your logic probes. It's a good place to start. Go ahead and take, I know it's extra wire, run them up to your 8 lights, and you can then show it on very clearly and step through this. Okay, so we have our demultiplexer working. If we had them, we're not going to build a multiplexer, but if we had a multiplexer in here, it'd work the opposite. We'd have 8 inputs and we'd have 3 possible outputs, and we would show the binary combination of those outputs for whichever specific input had been set.